Hello everyone. In this video, I'm going to explain you about the process involved in the look-ahead LR parser. So, the main aim is to do the input parsing here, and it has the steps. All the initial steps are same as your CLR parser till the table creation. That is first step is you have to convert the grammar into an augmented grammar, and then you have to perform the canonical conversion process. Everything is the same. So what you have to do is after the canonical conversion process, you will be deriving a table. Say for example, this is the table which we have derived for the CLR process, canonical conversion process, canonical LR parser. Okay. So, what are we going to do after this? So, once we derive this part for the LALR parser, we just have to do few more steps so that we can arrive at an LALR parser. So, what are those steps? In your canonical conversion process that states, you need to check for all the states um, that has got same production but with different look ahead values. Earlier, for creating the new states, we usually check the productions. We usually compare the productions with the earlier state productions, and if the productions as well as the look ahead values are same, we give the same state name. Otherwise, we give a new state name. Okay. So that has been checked already. But now we have to check one more process. So one in the canonical process, what you are going to check? Check in any state that has same production but look ahead is different. So for the CLR parser, for the CLR parsing process, if you go to the canonical conversion process, you can check that I3 and I6 states are having same set of production, but they will be having different look ahead values. So here you have same production, but different look ahead value. Okay. As well as you can find similarly I4 and I7 are having same production as well as different look ahead value, and then I8 and I8 I9 states, 8 and 9 states also having same productions and different look ahead values. And one more thing you can see here, for these two common states, that is I36, I47. For these two common states, you can check the transition has been done over the terminals. Say for example, this is obtained over I0 comma small a, and this is obtained over I3 comma small a. Okay, so small a. Similarly for this also, 0 comma d, and then 3 comma d, that is with terminals. So for these two things, the transitions have occurred over the terminals. Whereas when you see over here, these states have been derived uh, by the transition over a non-terminal capital C. So I0 comma capital C, and then for the I9th state also, it has been obtained over the transition over the non-terminal capital C. So, if the transition, if the states have been occurred after the transmission over terminals means, then you call that the operation as shift operation. shift action you need to take. If the transition uh, the new states have been derived after the transition over a non-terminal, then you call that action as a reduce action. Okay. So what we are going to do is you're going to combine the common states. So 3 and 6 will be now on, it will be called as 36. 4 and 7 states will be called as 47, as well as 8 and 9 states will be called as 89 from now on. So in the table, wherever we have yes, that is 3 and 6 or 4 and 7, it's going to be changed as 36, 47 and 89. Okay. So let us draw the new table as per the um, combined after this rule. So the set of terminals for the action column, and then set of non-terminals, capital S and C, representing the go to table column, and then the row values. So we have totally 9 states, but now we have merged a few states, 0, 1, 2. What about the state 3? I3 is being merged with I3 and 6 are merged together. So it will be, the state name is called as I36. Similarly, 4 and 7 are merged and it's called as 47. And then state number 5. So after 7, you have 8. 8 and 9 is also merged. Now you need to merge the values as well. So for 0, in 0th state, if you check, you got 3. So wherever you're having 3, now the state has become a merged state with 36, and 4, it should be written as 47. So those things has to be written in that way. So here you have shift 36 and then shift 47. Similarly here, shift 36 and shift 47. Here also 36 and 47. And then here we have for $1 and dollar, it is accepting state, and for the non-terminals in the go to table, it is for 1, and for I2 it is 5. And just check, for 3 and 6 are merged, so the values should also be merged and written like 89. Okay. Similarly, for 4 and 7, the values are being merged. So when you combine both the values, both the row values, your new value will be R3, R3, and here it is R3. Okay. And then here you got R1. Similarly, for 89, the rows of 8 as well as 9 are being combined or merged. So you get these are the new row values. So thus we have derived the LALR parsing table. Now we can perform a parsing process for any given input. So this is LALR parsing table. Okay. Let us do an input parsing. Consider the input string ADD. So it will be the data structure which is used for the implementation is stack, and then you got the input buffer, and finally the action taken for any two pairs. So it's exactly the same thing like a CLR process. So the stack will have, the base of the stack will have 0, and the input what they have given, it is ADD, and the end of the buffer is indicated with a dollar. So the first pair what you are taking is top of the stack and the first input. So it is 0, A. Now check in the table, the LALR parsing table 0, A, what it is? S36, which means shift along with the number 36, S36. So shift the value from input buffer to the stack, so it becomes 0A, and this is the input buffer right now. So along with the shifting process, you need to push the number 36 into the stack. So it should be written like this. Okay. So now we have 36, the top of the stack contains this one, 36 comma D. Check for 36 comma D in the table. It is S47, which means shift the number and also push the number 47 into the stack. So 0A 36, shifting the value D and then push the number 47. So the buffer becomes D dollar, and now it's 47 comma D. What is 47 comma D in the table? It is R3. So reduce with third production. What was the initial grammar which is taken? That is from CLR we are deriving this. The third grammar is C tends to D. Okay. So D47 should be replaced with capital C. So now the stack becomes 0A36. Okay, and the buffer has D dollar. So we have done a reduction process. So we have one more step to perform, which is you need to look at the go-to table for the values for the previous two values, which means 36 comma C. Okay, so the pair which you have to be looked at the go-to table is 36 comma C. So 36 comma C, when you see in the go-to table, what you're having, the value which is available there is 89. So push that into the stack, 0A 36C 89, and here it is D dollar. And now we have got the top of the stack 89 comma, and the buffer is having D. So what is the equivalent value in the parser table? It is R2. R2 means reduce with the second production. The second production is C tends to AC. So here A36 C89 completely it will be reduced using capital C. So here you have D dollar. So once you perform the reduction operation, you need to do a look ahead with the top two elements of the stack. So which means 0 comma capital C. So check in go to table. What is the number you are having? You are having number 2. Okay. So push that value into the stack 0C2. Then D dollar. So we need to check now 2 comma D. The table has got S47, which means you need to shift an element to D. Also push the number into the stack 47. Okay. So at this step you need to check for 47 comma dollar in the parser table. 47 comma dollar is R3. Reduce with third production, C tends to D. Okay. So this D47 will be reduced with capital Z. So the stack becomes 0C, 2C. Here it is dollar. We have done a reduction process. So one more step we need to perform, that is using the top two elements of stack. Check in the go to table. So what does it have? It has the number 5. So push it into the stack. 0C, 2C, 5 dollar, and now 5 comma dollar you have to check in the parser table. What is that? It is having R1. So R1 is reduced with the first production, which is S tends to CC. So CC means it's C2 and C5 here, 0 capital S dollar. So after a reduction process, you have to do a look ahead in the go to table. So with the two values in the stack 0 comma s, it is 1. So you have to push that element into the stack. So now taking 1 and dollar, checking into the parser table, it is accept. So thus you have arrived at the accepting state, which means the given input string is parsed successfully. So the given input string is parsed successfully using the LALR parsing process for the given grammar. Okay, thus we have learned about the LALR parsing process. The initial steps are same as your CLR, and then you have an additional step, this one, that is after the canonical process you need to do this step, that is combining the states that are having same production but with different look ahead values. Okay, so you will combine the shifting values, and then the reduction states also can be combined, and based on that the table will be reframed like this, and then the input parsing process is the same, that you do either a shifting or reduction based on the action which you see in the parsing table. Okay, thus we have learned about the LALR parsing process. Thank you.